Hello everyone. Hope you all are doing well. Welcome to Diplomat's Desk. I am your host Meet Shah. Imagine two identical clocks, same design, same atoms, same precision. Now place one on the ground and lift the other just a few meters higher. After some time they will disagree. One clock will show that more time has passed, not because it's broken, not because of engineering, but because time itself flows differently. Pause. Today, we are not just talking about space. We are talking about time as a physical phenomenon. From planet Earth to black holes to quantum reality. This is the journey from the familiar to the fundamental. We treat time like a background clock, seconds tick, minutes pass, yesterday becomes a memory. But physics tells us something unsettling. Time is not universal, time is not absolute, time is affected by gravity, speed, and quantum uncertainty. In modern physics, time is not just something we measure, time is something that can stretch, slow down, and possibly emerge. Let's start where we live. Here's the key idea: gravitational time dilation. In Einstein's general relativity, gravity is not a force pulling object. Gravity is the curvature of space-time caused by mass and energy. And when space-time curves, time itself curves with it. The stronger the gravity, the slower time flows. So a clock at sea level ticks slightly slower than a clock on mountain, than a clock on a satellite. This effect is tiny but measurable, and crucially GPS would fail without this. GPS satellites orbit Earth where gravity is weaker and they move fast. Both effects change time. If engineers did not correct for relativistic time dilation, your phone's location would drift by kilometers every day. Relativity is not a theoretical, it runs your life. Now, here's where things get wild. Modern optical atomic clocks measure time using electron transitions inside atoms. These clocks are so precise that if you raise one by 1 centimeter, gravity changes its ticking rate. This turns clock into gravitational sensors. Time is no longer just a coordinate. Time becomes an observable quantity that responds to reality. In physics terms, proper time depends on space-time geometry, and clock measures that geometry directly. So time is not separate from space. Space-time is a single entity. Now, let's add motion. Velocity time dilation. According to the special relativity, the faster you move through space, the slower you move through time. This is not about engines or fuel, it's about the structure of space-time itself. There is a universal speed limit, the speed of light. To preserve that limit, space-time adjusts. If your speed increases, your time slows. This has been experimentally verified using particle accelerators, atomic clocks on aircraft, satellites. So, time depends on where you are, how fast you move. Already time is no longer simple. Now let's leave Earth. Black holes are where gravity becomes extreme. So extreme that space-time curvature approach in infinity. Near a black hole, space stretches, light bends, time slows dramatically. This effect is called gravitational redshift and time dilation near the event horizon. From far away, you appear to freeze near the black hole. Your clock almost stops. From your own perspective, your time feels normal, but the universe outside accelerates. This is not science fiction. This is direct consequence of Einstein's equations. Time becomes relative to location. With telescopes like James Webb, we are now seeing galaxies existing earlier than expected, supermassive black holes forming extremely fast, structure that challenge standard timelines. This suggests our models of early cosmic time may be incomplete. Time evolution of the universe may be more chaotic than smooth. Physics thrives on this. When observations don't fit, theories evolve. In 2015, humanity detected gravitational waves. These are not waves in space, they are waves of space-time itself, produced by black hole mergers, neutron-star collisions. When they pass Earth, distance, stretch, time intervals change minutely. Gravitational waves prove something profound. Space-time is dynamic, time can vibrate. The universe is not a silent movie, it has a soundtrack. Now we go smaller, much smaller, quantum mechanics. At the quantum scale, particles exist in superposition. Outcomes are probabilistic. Measurement affects reality. Here is the problem. Quantum mechanics assumes time is fixed, relativity says time is flexible. These two theories disagree about time. That's one of biggest unsolved problem in physics. What happens if clock itself is quantum? Imagine an atom in two locations at once, each location experiencing different gravity. The clock accumulates two different times simultaneously. This is called quantum time dilation. It suggests time may not be a single number but a quantum variable with uncertainty. Proper time may subject to quantum superposition. This is not a philosophy, this is a testable physics. Now, something strange. A time crystal is a quantum system that repeats its behavior in time without energy loss, breaking time translation symmetry. Normally, physics laws don't care when something happens. Time crystals violate that expectations. They create temporal structures, not time travel, not motion forever, but a new phase of matter where time becomes part of order itself. This forces physicists to ask, is time fundamental or emergent? Some modern theories suggest time may emerge from quantum entanglement or from thermodynamic processes or from information flow. In these views, the arrow of time comes from entropy, not from fundamental equations. Interestingly, the idea that time is not absolute, that it's cyclical or dependent on processes, has appeared in ancient philosophical traditions worldwide, not as equations but as intuition. Modern physics is now testing these ideas mathematically. So let's summarize. Time slows in gravity, slows with speed, stretches near black holes, vibrates as gravitational waves, becomes uncertain in quantum mechanics, may not even be fundamental. Time is not a background, time is participant. And the deeper we explore the universe and more time stops being a clock and starts being a mystery. If you enjoyed this journey from planet Earth to the edge of cosmos, this channel is about thinking deeper, questioning assumptions, and letting science reshape how you see the reality. Next episode can explore do black holes destroy information? Is space-time made of quantum bits? Did time exist before the universe? Until then, stay curious because the universe is stranger than imagination ever was. Thank you for watching this. See you in the next one.